Yeah, thank you very much. This is not the start of this presentation. Here we go. So yeah, thank you for the introduction, and also thanks, Sarah, for this great introduction to the topic, because that takes away quite some pressure and time from me. So I will present a project from my PhD. So unfortunately, I'm not a doctor yet, but probably soon. So it is about the link between green space and adolescent mental health. And in this project, we were particularly interested in the different types of space and whether the type of green space matters. So when we think about adolescence and green space and the link between green space and mental health in adolescence, we could approach the question by just asking adolescents what they want. You know, what do you do in spaces? What do you want from these spaces? So this is essentially thinking about intentional visits. So why do they go to green spaces, and what do they do there? And what do they want from their spaces? So what makes spaces attractive for them? And typically when we ask adolescents, they report that they go to green spaces for physical and social activities mainly. And they like to have playgrounds and sports areas and trails, and they also value greenness. So from this from these reports, we can maybe already infer what spaces may be a bit better for them. So for example, spaces that may be more maintained. So they, spaces that actually offer these trails, sports areas and playgrounds. But then at the same time, we also have to think about the incidental exposure. So all the exposure that is not intentional. So adolescents don't go to spaces to use them, but they may walk past a green space or through a green space to a different destination, or they may just breathe cleaner air because they live in a green area. So all these effects are also relevant, and they may argue for different types of space. So the kind of ultimate question, what works best, so what do we need to provide for adolescents, is not simply answered by just asking them for their preferences. Also because often these studies, or typically these studies, don't link those reports to actual health outcomes. So here are just a few examples from London, which is the study area of this project. So this is just to illustrate that, of course, when we talk about green space, we have all these different types of space. So even, gardens and parks, they have different sizes, different features. It may be even just a small patch of green, or it may be one of these nice sort of more private gardens in London that are very pretty, but often have these restrictions. So not everyone is allowed to access them. Or even if you are allowed to go in there, you're not allowed to be noisy. So, it's quite a restricted experience, or it can be. So the question then still remains, what works best? So, and this is essentially the motivation for this study. Does the type of green space matter? And in the study, we used understanding society data, youth data from ways 1 to 8. So this is data reported by adolescents at the age of 10 to 15 years. So it's all self-reported data. And our exposures were also taken, from green space information for Greater London, the data that Sarah used as well, but also from London Green and Blue cover data. So these were external data sets that we used to create exposures and then link to understanding society data. And I will explain these in a second in more detail. For the outcomes, just a brief overview. Essentially, we distinguish between mental health and well-being, similar to Sarah's study on adults. So for the mental health outcomes, we use the Strengths and Difficulties Questionnaire, which is a measure of, or screening measure of mental health problems in children and adolescents. And it has 4 difficulty scales and 1 sort of combined total difficulty scale. And the SDQ was measured at waves 1, 3, 5, and 7, so not at all 8 waves that we used. And then we also used mental well-being data, self-esteem measured at waves 2, 4, 6, and 8, and happiness or life satisfaction measured at waves 1 to 8. For the exposures, as I said before, we used external data, Greenland cover and Greenland use. That's the way we distinguish these different data, because the Greenland cover data taken from London green and blue cover data is essentially a measure of any green cover. So it doesn't tell you what type of green that is. Is it a tree? Is it a green roof? Is it just a patch of green? But it essentially measures every bit of greenery across London. So it just tells you this area is green or it's not green. So it's quite a simple measure, but it's a good approximation of the greenness of an area. And then from these data, we only included the green cover, so we didn't look at the blue cover, simply because there's not that much blue space in London, and it was just not the focus of this study. And then from the green space information for Greater London data, we did not use the same data as Sarah and her colleagues. So we didn't look at these designations in this study, but we looked at the different open space types in London. So GIGO provide these open space data. There are over 12,000 open spaces in London, and each of these spaces is categorized into one of 10 open space categories. And in the study, we only included 3 main categories: parks and gardens, natural and semi-natural urban green spaces, and outdoor sports facilities. And these are essentially the largest categories. And they are also clearly, to some extent, green, and they have more or less a clear function as well. So that's why we focus on these categories for the study. And then importantly, and this links to what I said before about the access, we only included those open spaces that are actually free to access. So quite a few open spaces in London have no access or restricted access. And for this measure, where we really look at Greenland use, so space that is also to be used, we thought it is important to exclude those that can't be freely accessed by everyone. For the passive effects that I mentioned before, one could argue, maybe include all the spaces, because even spaces that you can't access have these passive effects. And that's definitely a fair point. But the justification here is that these spaces would be included in the green cover data. So if these have strong effects, then, or if there are these passive effects, they should be covered by the green cover data in this study. So this is just to illustrate the impact of excluding those spaces that are not free to access. So on the left side here, we see all the open spaces that GIGO provides. And then on the right side, we see that there's quite a dramatic decrease in spaces included, because and especially those spaces on the outskirts, they are just not free to access. And then in addition, from these open spaces, we only used those 3 categories. We didn't use all these other spaces. So what you see here is not quite what we then included. It would be even fewer spaces. So using these 2 different data sets, Greenland cover and Greenland use of open space data, we calculated percentages for different types of areas. And we calculated percentages for 5 exposures or types of space in total. So the green cover that I just described, but also the parks, gardens, natural and semi-natural urban green spaces, and outdoor sports facilities, and then combined those 3 into one Greenland use variable. So together we had 5 exposures of interest. And we calculated these percentages or proportions for lower layer super output areas and also at postcode level. And the postcode level analysis was then sort of the main analysis of interest here, because as Sarah said before, it is, even if not perfect, it is a bit more precise than the LSOAs, because the LSOAs are these, geographic areas that also vary in size and in shape. So knowing that an adolescent lives in an LSOA it doesn't tell us much where exactly they live there, and depending on the size of the LSOA, that's all. It isn't very precise. So the postcode level is our main analysis here, and in particular, what we did is we used a Euclidean distance to build this 500-meter buffer around each postcode centroid. And then in sensitivity analysis, we used different buffer sizes, and we also explored distances to the closest green space. Just because, I think Sarah said that as well, we still don't really know how to best assess exposure. So we need to explore a bit as well. This is a figure just to illustrate the difference between Greenland cover and green land use measures, just to show they really do measure different things, because the Greenland cover, as I said, that variable that captures any bit of green, whereas the green land use variable is quite selective, so really only includes these very specific sites. And we can see that when we look at LSOA level and the percentages of these two covers, essentially, or types of space, we see that for Greenland cover, we get much higher proportions for each LSOA, and that is just due to the nature of the data. Briefly, for the analytic sample, as I said before, we were interested in youth and from London, so 10 to 15-year-olds from London. So the sample sizes you see here for each wave are youth in London, so that's not the whole Understanding Society sample. And we combined data of all 8 waves into one data set, simply because our sample sizes were quite small otherwise, so we wanted to make the most of these data. And then we had criteria, so of course they had to have at least one valid data point, or valid data for one outcome at one study, and they also had to have a non-zero study weight to be included. So that's why we have a small decrease there in sample size. So to test whether there are any associations between these different exposures and the different outcomes we had, we essentially ran regression models, linear regression models, quite simple, but we had to make a few decisions on the way and adjustments. So I'm just going to show you quickly, or list quickly, what we considered and did. So first of all, as I said before, we pooled those cross-sectional data sets into one data set. But because, and I think I didn't make that clear on the previous slide, but essentially some individuals have multiple observations across waves. That's why the number of observations was much larger than the number of individuals. And to ensure that we only have one observation per individual in each analysis, we stratified our models by age. So we essentially ran separate models for each age group. And that means that we ultimately ran one model for each outcome, exposure, age combination. So we had quite a few models here and quite a few results, which we will see in a second, made the interpretation a bit tricky as well. We imputed data, missing data on covariates, simply to not lose even more or decrease the sample sizes even more. We accounted for Understanding Society's complex sampling design. Also importantly, we transformed the green land use variables. So essentially parks and gardens, natural and semi-natural and green spaces, and outdoor sports facilities. Because there were only few spaces included, that meant that in a 500-meter buffer, the chance was quite high that there was 0% of green land use in this 500-meter buffer. And then we also had quite a few extreme values. So we wanted to make sure that these very extreme values don't have too much of an impact on the results. So we transformed the green land use variables. We didn't have that problem for the Greenland cover because that was really nicely distributed. And then finally, we adjusted for neighborhood, family, and child confounders. That's also something that Sarah mentioned, that sometimes studies don't adjust enough, so results may be confounded. But we attempted to adjust as much or appropriately as possible. For the results, I can't give you a nice plot as Sarah did because, as I said, we had quite a few models. We had several outcomes, several exposures, several age groups. So that meant we had lots of effects or, well, results or coefficients to interpret. And unfortunately, it was really mixed. So the results were not clear at all. So it was really difficult to make, any strong inferences or draw any clear conclusions from this. So results were mixed. Overall, really only very few associations. But we did identify a few patterns, sort of looking more closely at the data or the results. We found some things that were interesting and should be explored further in future studies. So one of these was that it seemed that we found positive associations, so essentially more green space, better mental health, only in older adolescents, and negative associations in younger adolescents. This pattern wasn't perfectly consistent across sensitivity analyses, but it did emerge, and it may be interesting to actually look at that further, because when we think about adolescence as quite a complex period of life with lots of rapid changes, it may well be that 10, 11, 12-year-olds may have different needs, for example, than 13, 14, and 15-year-olds. So this was one of the patterns we found. And then also in these positive associations in older adolescents, we found these mainly for parks and gardens and outdoor sports facilities, not so much for natural and semi-natural urban green spaces, or indeed green cover, total green cover. Again, not consistent, so we have to be careful with these results. But it does sort of fit what I said at the very start, that adolescents tend to use these spaces for physical and social activities. So these spaces, types of spaces, would actually facilitate exactly that. So it's not too surprising, but it isn't perfectly in line with previous research that showed that maybe woodlands are more beneficial than other types of space. So we definitely need more here. Just a brief summary and discussion. So essentially, we can't draw any clear conclusions. Some patterns emerge that raise questions for future research. And when we think about why didn't we find these clear associations, just like across all analysis, just this one effect of green space on emotional symptoms. So why didn't we find this very clear effect that would have been nice or at least easy to interpret? And I think one point obviously are the study limitations. I can't go into much detail now, but Sarah did mention a few in her presentation that do apply to our study. For example, the Euclidean distance, so how to measure exposure. Do we have exposure misclassification? I mean, we will definitely have exposure misclassification, but how much of an impact does that have? And there are several other limitations we need to consider. So we just submitted this. So hopefully in a couple of months, you will be able to read more into the study and the limitations as well. Just some thoughts why we didn't find these clear associations. So maybe it is the dip in nature connectedness in adolescents. Adolescents just seem to be not that interested in nature. They are not as connected with nature emotionally. So that may just also explain why we don't find strong positive effects. And then very importantly, the characteristics and the quality of green spaces, also the quality of the neighborhood, all these other contextual factors that will play a role in the link. We couldn't, or we didn't test these, so there may well be something there. So this really needs more research. I think the quality of spaces and the neighborhood is really important, as Sarah just demonstrated with her study. And then maybe we also need to think more about these informal, other types of green spaces that we didn't include that may be relevant for adolescents. So just, they go around the corner with their peers and they just want to hang out in like this little Greenspace that we didn't include in our study. That's all possible. So yeah, definitely more research needed. Yeah, hopefully you will have the chance at some point to look at the paper where you get way more details than in this, or than from this presentation. These are the references, and then I would like to thank you for your attention. Of course, thanks to the team, my supervisors and committee members, and also the funders, the Leverhulme Trust. And yeah, that's all from me.